As requested, I'm going to step by step go through the development of the client and server example that we did in lecture. I'm going to start with the server. As I said in lecture, it's often easier to start with the server because we can use Telnet to connect and test that the server is behaving properly before building the client. Helps us to separate out where errors might be occurring if we can test that the server is definitely working first. So I am going to start over here and create a file called server.c. And again, you can use whatever editor you want. So I know that I'm going to have various parts of my program. Go ahead and put in the main. And I'm going to go ahead and put in the comments of what I need to do. So I know I'm going to need to create a socket. I know I'm going to need to bind to that socket. And then I'm going to have to listen on that socket and then accept connections on that socket. And then I'm going to need to read and write to connected socket. And finally, I'm going to need to close my socket. And of course, the read and write I might be doing multiple times, depending on whether I read a single instruction or whether I read multiple requests. So let me start at the top. Let's create a socket. Now, to create a socket, we use the socket command. And it's going to take an address family like AFINet and the type of socket like datagram. Now I'm going to fill this out from some hints, so at the moment I'm just going to leave myself a note. Generally, if I don't have my notes handy, ignore that, then I will search for socket to get the definitions of the actual function. And you can see that it's available in several places that you can look at. And likewise, if you're interested in Windows, you could search for socket with Windows and it will give you the specification for the Windows sockets. It doesn't really matter which one I choose. I'm on a Macintosh, so I'll just choose any of them. So I can see here that to call socket, I need the domain and the type and the protocol. Down here I can see the possible domains. You can see INET's the one we've been using, that's IPv4 if you want v6, INET6, and there's various other ones you could be using as well. So I've got amateur radio, Apple Talk, and so on. So it's not limited just to the internet protocols. It can use other protocols. And then the type is whether we want to stream socket like TCP or datagram socket like UDP, and there are other options as well. Okay. With the protocol, as I mentioned in lecture, we have the number available in case there's more than one stream socket that you could choose from. So say, for instance, if the internet had 2 stream socket protocols, then they could have different numbers. But generally, there's only one stream protocol per network family, and so we can just specify 0, and that will just take the first one, the default one. Okay. So going back to my code, I notice that I have the domain, that's fine, I'll get that. The type, that's fine. The protocol, I know I only have one, so I'm going to leave that as 0. I also notice here that it tells me what include files I need to include. So we'll go back and add those as I go along. So it says I need those two, so I've added them in. So my next step I'm going to take is, well, let me go ahead and get this family information. We looked at that structure and we spoke about setting up the hints to get this particular address. So we said that the information that the server is going to use to bind to is stored in an struct address info or ADDR info structure. Okay. I called it server address. Now you can call it socket address or whatever you want. To use this, we're also going to have a hint structure, which is the same type. The difference is that this first one is where we're going to actually store the final information. The hints allows us to fill in some of that information ahead of time if we know the type that we want. For instance, we know that we want a stream socket. So we're giving hints to the type of connection we want and allowing getAddressInfo to fill in the rest of the information for us. As I mentioned in lecture, C does not guarantee that your any variable is empty. It just has a space in the memory and it could contain garbage in there. So first thing we want to do is clear out the memory that's being referred to so that it actually doesn't store any values that could accidentally be interpreted as being valid values as opposed to being empty. So I'm going to use memset. You will look, as I mentioned in the, if you look in the tutorial, you'll see they use bcopy. Bcopy is not portable and it's deprecated, so memset is a better option. So I'm going to set both hints and server address to be full of zeros. It's basically saying take the value hints, fill it with zeros, and I want you to fill it with the number of zeroed out bytes for the size that hints is. So it basically says take the whole thing and put zeros in it. Likewise, I'm going to do the same thing with my server address. Excuse me. To make sure that my variable names match up. Okay, so I'm zeroing out all my structures. There we go. Now I want to fill in those hints. Again, if I want to know what's in those, let me Google an address info structure. There you go. We've got it for Windows and Linux, whichever one you want to be using. I'm on a Unix environment, so I'm going to choose that one. And in my address, here's the description of my address info structure. You can see I've got various flags I can set. Those are just options. The family, which is going to be INET for me. The socket type, which is going to be datagram for me. The protocol, which is going to be 0 for me. The length of the address and so on, the actual address. And this is the bit that's being filled out for us. Okay, we're just going to fill out these family and the type of socket that I want. Okay. Down here it explains you all the different types of AI families. Okay, it gives you their socket types, it gives you examples, and again, more details, and so on. I also know that if I'm going to be using getAddressInfo with this information, I need systypes.h, which I've got, syssocket.h, which I've got, and I'm also going to need include netdb. So I'm going to add that up to my list of includes. So using that structure, I am going to set AI family, this one here, to AF INET. Okay, that gives me IPv4. I also know that I want TCP, so I'm going to set the AI sock type of the hints to be a stream socket. So this is effectively saying use the IPv4 stream socket. Because I'm on the server, I'm going to set one other option. This isn't required. I could go ahead and fill out the server address like I do with the client, but I don't have to because I know the server is running on, it's obviously running where I am. I can tell the operating system, hey, just set the address to be my address wherever I'm running on. And I do that by setting one of those flags, and I set it to AI passive. Okay, so I'm setting one of these flag options, and it also describes that down in here. Okay. The AI passive flag is specified, and the node is null when you call getAddress, then the return socket address will be suitable for binding to the socket that accepts connections. So it's effectively like using the inaddress any in the other example, in the old style that you have in your code. Okay. So you can think of that's the replacement for the setting the inaddress any. Okay, so we've got the flags, and we are now ready to get the address information filled out for us. Because we've set the AI passive flag, we can just say null here. Otherwise, we'd have to tell it what the host is. And we can pass it the default port. We tell it the hints of what we want our structure or our connection to be. And we tell it where to write the results. So what happens here is that getAddressInfo, we notice it takes the host node, the service, which is the port number, or if you know that it's HTTP, you can just write HTTP and it'll fill in port 80 for you. It takes your hints that tell you what you want, and it takes the result and it puts them in there. So that has filled all of that server address out. It also allocates space for it. So we will use FreeAddressInfo later to free the memory that's been created here by getAddressInfo. So having filled out that address, now I can go ahead and create my socket. The socket needs this address, okay, and it needs, sorry, it doesn't need that. It needs the family and the type. Okay, it's when we bind that we're going to need the address. So I filled that in. I could just write AFINet here. That would work fine. But since I've already got it in hints, I'm going to use my newly filled out information and get it from there. Now notice that server address is a pointer, so I'm using the arrow to get the AI family as opposed to the dot. Here, hints is just an address info structure, so it's not a pointer, so I use my dots. Here it is a pointer, so I use my arrows. So, and address AI type, or subtype. Okay, so I've got AI family, AI sock type, and again, the hints is all copied into server address, and then all of the rest of the information is filled out for you. So I've got my socket all ready to go. Better store it somewhere. So listen socket is going to be my socket that's listening. So I'm going to go ahead and create some variables to hold on to my socket. Just like files, what's actually being returned by the socket is a descriptor, which is stored as an integer. So it's just a number that we use to refer to it. Okay, so listen socket is going to be my new socket that's listening. Now I need to bind that to that address that I have set up here, server info or server address.